Welcome, everyone, to the Analytic Minds podcast. Today, I'm excited to be joined by Doug Rahden. Now, I'll let Doug do a much better introduction in a second, but high level, he is a senior manager of advanced analytics at Cigna. And Cigna is a huge, huge company, mainly based in the US, I believe, around health services. And is there maybe some insurance in there as well? Doug, would that be right?
Yeah, heavy insurance and globally. Yeah.
Oh, okay, right, yeah. Um, cool. Well, I mean, you can just expand on that a little bit much better than I can, and then we can sort of just kick off the discussion. I mean, there's plenty of great stuff I want to cover around the advanced analytics things that you would do in such a large organization, and like from right from the beginning, like how you actually decide what to focus on prioritize to actually executing on those sort of projects within such a large organization. So I'll throw it to you, and you just sort of dive a little bit deeper into yourself and how you've got to where you're at.
Sure, you bet. I'll get started with me a little bit. So do need to get this out of the way. What I cover with
Yeah,
you here is going to represent my own opinions only. I'm not here to represent any official position of Cigna, and I can't really blame them for making me say that because to that end, I have to acknowledge that I work in a unique, cool, I think too, but a unique place in the analytics world. So
right.
I'm actually embedded within the fraud unit within Cigna. So kind of a double whammy of privacy concerns there, right? We we have medical data that's a bedrock in the industry for what we do, and then we also have sensitive law enforcement data, law enforcement from federal law enforcement and government law enforcement agencies all over the world. So um, certainly certainly some sensitive stuff. Um, yeah, I can give you a quick little, maybe high level of what it is that what that means. I guess my title, maybe, or what my team kind of does, and then my background in it, and where I kind of came from, because everyone loves talking about themselves. So, um, the space that we're in, we're here to protect Cigna from health insurance fraud and any other fraud or similar kind of white collar crime that could potentially impact the organization. That's our role here. And sometimes when people hear that, the first thing they think is, "Oh, we're here to deny claims or or something." I think it's been my experience that almost I've worked with a lot of different other payers, insurance companies. Literally spoken with maybe up to 100 different folks at hundreds of different companies, and the priority typically actually is patient safety and protecting the public from kind of bad doctors. Really, any party in a transaction could potentially be criminal. But typically, it's the providers that were the bad ones that we're trying to root out and protect people from. So, but very very interesting work. I like it a lot. And my background kind of is a little bit odd. I got into this industry by accident. I think if you would have told me where I was going when I was in college, I would have laughed in your face. I was an undergraduate at Brigham Young University, and I was actually a pre-med student. I was going to go in that direction. All my friends were pre-med, and they all were smarter than me, became doctors. And I was very lucky. I actually had a mentor as an undergraduate who was a physician, and he picked up on something with me. I don't know how in the heck he saw it, but he basically said, you seem to be good with data and numbers. Maybe you want to look at analytics or epidemiology is what he was kind of pushing, and that sent me for a tailspin for a moment because I was like, what is epidemiology? What is data? Is this a career path? And I had done an internship at the Utah State Prison when I was an undergrad as well. So I had this weird background of like of studying a little bit about healthcare. I was volunteering in an emergency department. I was interning at a prison. I had this weird law enforcement experience. And when I graduated, I had this maybe what I would consider odd directive from my mentor. And I was kind of lost. I was like, "What am I supposed to do here? What is this?" So when I graduated, I ended up being picked up by a place called the National Insurance Crime Bureau, and they said, "Hey, we need someone with a little bit of background in medicine and a little bit of background in law enforcement, kind of be able to understand those areas." A lot of training would come, obviously, but became an analyst and kind of rose up the ranks. over there at the National Insurance Crime Bureau. The National Insurance Crime Bureau is kind of like a quasi-governmental organization in the United States, there to work with very closely with federal law enforcement and then all their insurance company partners. So that's kind of where that all started for me. It was a great experience to work there as a analyst, a fresh young analyst when I was at the NICB. It wouldn't be uncommon that we'd write a fraud report, and then that night it'd be picked up by CBS News nationally and broadcast to the world. That was kind of
Wow.
it was kind of a cool experience. But I like to focus on the medical side when I was over there, and was always interested in going to a health insurance company just because of the massive data that they had compared to some of the other insurers that I had worked with. So it was a few years later, I ended up joining up at Cigna, and here I am today, basically leading the analytics team embedded within what we call the Special Investigations Unit at Cigna, to identify fraud and risk throughout the enterprise across all lines of business. And I'll end with maybe a little a metaphor or story here on my background. But when I was doing, I mentioned that Utah State Prison internship that I had. It was a really interesting experience. It has nothing to do with analytics, but it was a very interesting experience. And one of the most cool things about that is, many interns and employees at the prison, you kind of work in your one area. You go to the drug unit, and that's where you spend all your time, or you go to, you work in maximum security or whatever. Um, I was in a unique position where I was able to conduct psychological interviews and work with inmates from all over the prison population. So supermax, death row, medium security, the women's prison, the drug unit, the gang unit, and that was something that I absolutely loved. I was always kind of going all over the place. Maybe a bit of a dark metaphor, but in the analytics space, that's kind of what my career turned into when you go into audit or you go into investigations with analytics. Is that we are working with all types of data on a daily basis across the enterprise. We're not, a lot of data scientists or analysts, not that this is bad, but it just wasn't my cup of tea. You're kind of handed a data set or a data point that you're supposed to analyze, and you kind of work in the confines of that project, and then you kind of go forward, get it done, and on to the next thing. The cool thing about being a data scientist or an analyst in the fraud space is you get to flash your badge, so to speak, and literally go to any area of the company and get access to whatever data you want, because there's that expectation that you're there to find fraud and risk, which is of course a pretty big deal to almost everybody, which I can talk more about later. But
Mm.
that's something that I love about my job, and I think everyone that I get to work with, everyone I get to lead, I think they like that too. We get to
Mm.
work across all lines of business in the enterprise, and that's common, I think, with a lot of data scientists and analysts who work in SIUs and in the fraud space, or even as data scientists or analysts for the government. You're working on a wide variety of data access, not stuck to a single area. So yeah, a little
Mm.
background there, I guess, about me and the unique world that that the fraud analyst lives in.
Yeah, that's great. I mean, I love hearing such a unique background. Yeah, and to have unique bringing unique experiences into the analytics space, I think is a great thing. And I think that you know, if you're just someone who uh, is quite singular in their mindset or focus, I think you can miss the real story. You can't tell the story as well as it could be told if you come from this diverse backgrounds of human knowledge, but also sort of like business knowledge. I think that's really, really fascinating. One of the interesting things, and this has been really common in a lot of the discussions that I've had through this podcast, is if like, almost everyone is coming to analytics in slightly different ways, because it's an emerging field. Like in the last 20 years, it has changed so much. It's kind of like, there was no website developers before the internet, right? And everyone had to become a website developer. Like I feel it's very similar in the analytics space, especially with it just wasn't possible with a lot of the tools, etc., that we had in the past. And so I think that the space is just absolutely booming, and there's all of these opportunities that are opening up for individuals and organizations also. that want to, explore the value that can be generated from what can be done. So it's not it's great to hear your unique zigzag that zigzag of how you've got to where you've got, but I truly believe that it's actually not that rare. Like everyone is coming at it from different things. Like even myself, I'm from a finance background, but then I sort of was in finance and I realized, everything's turning out to be about data. Like everything, like even in finance, it's all about analyzing the market information, analyzing your customer information, all that kind of stuff. So really, really interesting.
Yeah, yeah.
Now, so you touched upon this. You have a real diversity in data sets or data scenarios that you're dealing with, and huge volumes of data. I mean, it's just be absolutely crazy how much data that you could potentially deal with. So how are you actually going about working out what data is most relevant to some project that you're working on? Or what sort of processes do you have internally that enable you to locate or find this data quickly so that you can get an answer or get a result or get an insight that is going to add value to decisions?
Yeah, no, that's a great question, and you're right. It is a huge variety. I remember being at a international fraud conference not too long ago, maybe a year or two ago, and hearing about challenges of some of the data and using a variety of different data sets in that context. When I came to my current role, as I guess it could apply anywhere, and it certainly applies at a lot of the different payers, a lot of the different companies who write internationally. But folks are, if you talk into an American data scientist that works in finance, for example, you're used to seeing some very basic information on numbers. It's kind of wild, frankly, to come into a situation where you're opening up a data set and nothing's in English, and they're trying to define complex medical procedures or financial
Right.
information or whatever, and it's literally not even in English, and you're trying to decipher it.
Right.
Yeah, there's certainly. I think a lot of it is probably not too shocking. It's you kind of go and where the biggest need is. You kind of have to triage it, right? What areas are we in our context? What are we not? Are we concerned that we're not protecting to the level that we'd want, or we want to kind of upgrade? Hey, maybe we're looking for A, B, and C already. We're doing a good job there. We're tracking that. We're uncovering fraud there, but maybe X, Y, and Z, with this line of business, we're not checking into yet, and we need to be, and so we're going to refocus efforts there to grab that. But I think there's a second part of that equation, which has to do with the challenge of working in the variety of data sets, which is to uncover X, Y, Z in that other data set, where another three variables in another, it's apples and oranges. Some of the lines of business, some of the data sets themselves can be much harder to work in. If I want to do, for example, a simple analysis of identifying how much we're paying a given doctor in one data set, that analysis, real basic thing, real basic univariate stuff there, nothing crazy. It would only take me a few seconds to get some numbers there for that. But in another data set, that could take me days to do that. And so I think the challenge is that you have to kind of balance what you want to do and what your resources are, just like probably an analyst or a data scientist in any industry. But that a lot of times will drive our decision. In a perfect world, we'd have infinite time and be able to get to the exact same level in every data set that we work in. But in practicality, that's just not the case. You only have so many analysts. You only have so much time in a day. So you have to kind of, again, triage that a bit to get to where you need to be. But of course, even in situations where the data presents challenges, you nonetheless sometimes have to prioritize getting something done if you need to be at a certain point and you're not. So sometimes you do kind of have to dive headfirst into again, maybe, hey, this would take me seconds. Otherwise, it's going to take me days or weeks to get this done, but we need to get this done. And so you kind of have that balance of priorities and resources available, and you just kind of try to handle that the best you can. But when you or anyone else figures that out perfectly, has a perfect answer to that, let me know. I'm sure I've got room for opportunity for growth there myself to balance those priorities even better.
Yeah, I think it's one of the toughest things, and in a lot of cases, it's not actually about the specific analytical work. It's kind of like about the planning and strategy and how you identify where you're going to add the most value, and then how do you prioritize your efforts in that particular area. And yeah, I honestly don't think there's a perfect answer. I mean, I've talked to some that have created a scoring system where you know the return on investment or return on effort is a big part of what goes into the score, and then that is what you decide. That's how you sort of decide, or that's how you at least present up the chain. Like, this is what we should be spending money on. This is what we should be putting resources into. One thing that I want to get onto more advanced analytics, dive a bit deeper into that in a second. But what would be interesting is, on a sort of day-to-day basis, where are you finding that you spend most of your time? Like, especially what I guess what I'm trying to get at here is, when you're working on a data project, there's finding the data, there's optimizing the data, building a model, building a report, a visualization, reporting that, presenting that. I have my ideas around, or thoughts around how long it is based on my own experiences. But I was wondering, from your perspective, what do you find you are spending most of your time on?
Yeah, there's that classic. I still do this when I present to new data scientists or analysts working in my industry. If I get an opportunity at a conference where you got that big pie chart, right, and they say, yeah, what is the analyst? Where do you spend your time, right? And 90% of it is always data cleansing or data preparation,
Yeah.
right? You've got that little sliver that's 10% that's actual data analysis. Um, I think in some ways, I think the industry is getting better about that. They're trying to knock down barriers so that analysts are spending more time, data scientists are spending more time on what they're paid to do, giving them extra support. And my company is no different. They're making significant headway. I think just from like an employer perspective of trying to do that. And I'm seeing that at all the major insurance companies and kind of beyond. They seem to be working on that. Um, but certainly, in kind of my hyper specialized area, it's a huge challenge with fraud, just because that's one of the great benefits, I think, of what we do. One of the funnest things we do is accessing all these data sets. But when you're accessing so many data sets, you are not an expert in all of them. I mean, there's literally hundreds of them. So there's going to be 1,000 people that are going to be better educated with what this field means, or what this variable is, or how this was engineered, and how this is kind of laid out. So that at times can be frustrating, because it's common, I would argue, for a fraud analyst or a fraud data scientist to walk into a data universe, where they're looking at something for the first time, and they've got a big ask in front of them. Tell us what's weird and fraudulent here. We're basically at a superficial level. You have no information that indicates that. Go solve this complex question. Oh yeah, here's the data. This is what it looks like. I know you've never seen this before. Go run, do it. And certainly in our, not that our spot is the only one that has that challenge, but I would certainly say it's a big issue. And so unfortunately, sometimes we have to spend a little bit more time looking at it and saying, yeah, well, okay, what is this? What are these fields? What does this mean? How is this calculated? Why does this matter to me? And that's a time suck. It requires some resources. In our space, I don't have a perfect a solution to fix that. It just kind of seems to be, again, a pro and con game of working in the space of accessing so many different data points. But
Mm.
it kind of is, it is what it is, and at least keeps it fun if it doesn't require that big 90% part of the part of the circle to stay bigger. But we're working on it, and I think the industry is working on it, and I think we're making headway. If I were to say how much time I spent prepping a data set, cleaning a data set 10 years ago versus what we're doing today, I think we're spending a lot more time on actual analytics and data science, machine learning today than we were, all that time ago. So I think we're
Mm.
headed in the right direction.
Yeah, nice. Yeah, I think, yeah, you're certainly not wrong there. There's been huge improvement up and down the stack, for sure. And and definitely one of the things I want to touch on um, is your data stack and how you're actually putting that all together. But I think what would be first better to to dive into is more the advanced analytics piece, because advanced analytics is quite a broad topic. But how does that relate to what you are analyzing, what you're looking to investigate? I presume there's some machine learning in there. You touched upon that, but maybe things like anomaly detection, those sort of things. I would presume are some of the things that you would be covering. So, do you want to maybe just dive into what advanced analytics means to you and to what you're doing on a day-to-day basis?
Yeah, you bet. Maybe a bit of a little story, I think maybe captures this well. I had a coworker, not working. She wasn't working in the fraud space, but asked me. We were at the same company. Asked me, okay, what is it about what you do? Why is this so advanced or predictive or whatever? What makes this so fancy? Why aren't you guys just taking numbers from an Excel file and visualizing it? What's the big difference? And um, even after walking through some of the work we did, that question kind of remained for her. She was like, "Well, you say you're predicting something here, but I'm just seeing more data in front of me." And it was kind of an interesting thing, because if you could wrap your head around what I was actually communicating there, what actually is going into the predictive nature of data analytics, I think that's the key in that case. And in many cases, when we're in the fraud context, when we're looking at advanced analytics, it's about taking a set of data, and almost always for us going outside the box. A lot of times someone will, hey, here's here's a data set. Look at this data set. Obviously, we have a specific directive to look for fraud, but to them, it's just a claim system. It just shows different procedure codes and diagnoses and patient information, doctor information, prescription data, whatever, just all kind of dumped in there, and that's how they process a claim. But from our perspective, there's going to be elements of that data that help us identify, hey, this is a red flag. This looks like a bit of a straggler. This is a little bit different. But a lot of times, once we actually go into the mechanics of that same person who is asking me, or anyone else who's worked with that data set before, and we show them what we're doing, inevitably it leads to, well, how did you find that out? How did you find out that doctor was actually engaging in criminal activity based on the claims data, or whatever? That's I think kind of the part that, if you can wrap your head around it, it's the best description I can get is thinking outside the box, using the data in a way that it probably wasn't designed to be used before, and applying some very rich and exploratory feature engineering to that data, and then also applying some statistical methodology that, again, probably the maybe even the statistics itself weren't designed to be applied on, or the data itself wasn't necessarily prepped for. But you're coming up with new variables, and you're applying either some supervised learning process or some machine learning process to uncover some patterns that you didn't see before. And I can kind of testify to this. I mean, this is what we do every day. We're playing with the data, we're playing with the features, coming up with literally new ways to look at the variables that are presented to us, the data points that are presented to us, and then we're applying some pretty complicated sometimes statistical methodologies to identify where things go awry. And it's literally all we do. Yeah, and whenever we get to that point and we get to walk through the results, I always love that part. It's always interesting hearing people look at that and just ask, how did you uncover this? It's described in different ways. Usually the word magic is used, or something along those lines. But that's kind of that's what it looks like from a high level. I would say that's what advanced analytics is to me.
Yeah, I really like that. And what it makes me think about when you walk through some of those examples is, and I've related this a, a number of times over a few discussions, is you're almost like an artist. You need to think creatively, and
Yeah.
that's where I think that you can show or add the most value, or you can showcase the most value as an individual in this space, is if you can come at a problem in the analytics space with some creativity. and extract things out of data that no one would even think to have looked for. I think that is where the immense value add can be generated within any organization, really. A lot of these techniques can be applied over and over again in many different situations, and that's what really came to my mind when you sort of started talking through the sort of magic and the amazement of what you can achieve. And raw data doesn't always just tell a story. You've got to actually dive a little bit deeper and be creative, and you can actually find things that can produce really superior outcomes.
Yeah, you were just I wanted to just really double down on what you said there. That was said well. The creative component with creativity, that's key, and that's a unique element, I think, of data science in general. Not even just kind of like I said, my hyper specialized fraud space, but across all data science is that you need to instill creativity in what you're doing. If you lead a data science team, you need to provide the conduit for that to happen, because that's literally what it is. And you actually, in my opinion, I would go even pretty far here and say that you need to be careful, for those that lead data science teams, in making sure that your data scientists aren't experiencing burnout, or you're throwing too much their way. I've noticed that if I've got an analyst or a data scientist that's working on something, and they're overburdened, and we threw them too much data, they're trying to clean the data up and or prepare it, or they're just exhausted from that endeavor, or they're just dealing with too much. The creative elements of why we hired them are going to get shut down, and that's what they're there for. And you can really see that take a toll on somebody's work when they're not allowed to be creative, or they're not able to be creative. Sometimes I think that can be because of burnout or other reasons. But you need to provide that space. We use the word play a lot in the work that we do, right? We oftentimes will say, all right, well, let's get this prep so you can go play with that and figure that out. And we kind of really mean that. We just want to sit there and tinker around with it. That the data scientists play, explore, apply different methodologies, and be creative. And that's just a critical component. You hit the nail on the head with that, for sure.
Yeah, I really love that that line of thinking, because I'll just relate this back to even myself. I work in Power BI a lot. That's really what our focus is with my company, Enterprise DNA. And if I've had a busy day, or if I'm sort of swamped with emails, or just I feel like I don't have as much headspace, I find it really hard to creatively work in Power BI and design a compelling report that tells a good story. And I think that is totally related to what you've just talked about, is that just like an artist can get sort of like a mind block, or a songwriter can get or a storyteller can't come up with the next story. I think it's really similar. I think that there's a lot of commonality there, and I'm glad that you sort of dived into it a little bit further, because it's so true. And so maybe us analysts need to get into a lot more meditation. maybe that's the answer for us, to clear our minds and be able to get those creative juices flowing more.
Yeah, I think you might be onto that. I've noticed myself, for example, being burdened with meetings. For example, nothing stops a data scientist more in their tracks. And yeah, emails or meetings, you kind of need that creative, that creative space. Yeah, we're gonna remove some meetings and add some meditation. I'm gonna update Outlook here in a few minutes. I think you're onto something there. I like that.
Nice one. Now, just on some more like advanced analytics techniques that you're using. So, things like pattern recognition, threshold triggers is a term that comes to mind. Anomaly detection. And so, these are the sort of things that you're applying to your data sets internally. These are the sort of it sounds like they would be the sort of main things that you would be trying to identify within a whole range of data sets.
Yeah, that's a great question, and this might be a part of the conversation where I might step a little bit off course compared to other data scientists. Nonetheless, I hope it's kind of interesting because it's a bit of a different path. But
Yep.
in the fraud atmosphere, um, we are almost always looking for the 1 in 1,000, right? So it depends on the nature of your work, but some financial analysts, hey, if you're a data scientist working, looking at web analytics, or whatever, insert your industry here, it's very common that you're looking at maybe population A compared to population B, or you've got 10 different populations, or you're looking at a trend across that population where there's kind of an assumption that, hey, this is a normal distribution to whatever the context is that you're looking at. And I maybe want to see how that is trending, or I want to see how different populations within that distribution are moving about. In the fraud world, it's odd because we are always looking for the outlier, and so we use some different methodologies maybe than others would use. I've noticed that as I've talked with other data scientists, that they're not always up to speed with what we're doing on a daily basis, or we're applying things in a weird way that they're not used to seeing. And likewise, we're not necessarily experts at comparing three sets of populations versus another three, just because the work that we do. So and I think another part of this, that another element of this conversation, this might actually be a broader topic, which is we do use a lot of statistical methodologies, but I think one of the things that I have to acknowledge is that statistics itself kind of was born and raised and bred in a different world than we're in now, right? So if you think of, I guess maybe my, I'm not sure if it's my graduate work or my undergrad in psychology talking, but when you think of statistics, you often think of, hey, there's too many resources to grab. We need to, we're curious what this population of 10,000 is like, but we only have the resources to survey 500, or we only have the resources to, perform a medical procedure, whatever, on 500, or whatever it is. And so there's that assumption that you're always selecting from a population, doing an analysis there, and then applying that logic back onto the greater population. The weird thing is, not to use a huge industry term here that's probably overused, but the difference with big data is that you have all the data. You don't need to grab a select number from the population and make conclusions there and apply those to the greater population. You're in fact, your starting point is everybody. That's usually the problem, right? It's man, if I only had to look, I could only dream of a world where I only had 500 data points. That would be amazing. The problem is that we're usually presented with something, and you have, all right, here's 100 billion rows, and go have at it. And I don't know if the pedigree of statistics per se was designed for that in the beginning. Although, as it's evolved, there's a number of methodologies out there that can be applied, that still work. So now, I don't mean to demean it and say, oh, it's useless. So not at all. It's just sometimes you have to think about things differently. Sometimes if I'm looking at if I'm looking at an equation or an output of a model, for example, certain outputs of that model may be less important to me because I know that the population I'm applying it to is complete. So I don't need to be worried, about certain errors, for example. But once you can kind of acknowledge that, and I think maybe what you have to do is just kind of step back and take a breath and relax a little bit, because you know that the statistical methodologies that you're applying, there's a little bit of room for play there, and that the data that you're working with is usually more complete. So I guess that's the perspective that I have with statistics, and then the methodologies that are employed. It really depends. Sometimes we want to be able to take a set of variables on that billion lines of data or 10 billion lines of data, and we want to know which variables matter to what we're looking at. We need help feature engineering. We need to know which things matter in a model that we're going to develop, and so classification becomes kind of a bigger priority for us. Sometimes I always love the bread and butter. Like you can always apply different types of linear logistic regression to the data that we're using to help us identify, oh, something is standing out here, and kind of tweak the variables to identify hopefully what we're looking to get. But so that's kind of cool, bread and butter analysis, and then also applying machine learning techniques to what we're doing. I love going into the unsupervised space, looking at for example, if we're doing clustering, if we're employing some type of feedback loop. Feedback loops, I feel like, are a component of what we do that maybe at least in our industry, and maybe the specialized space is something I'd like to see grow more. But hey, if we've built a model, whatever it is, there are certain inputs going into that model that might adjust thresholds or even the model itself. And when you're adjusting the model itself, you're really moving in more into a machine learning framework. But I love for stuff to be more dynamic in our space, because the fraudsters, the bad guys, are evolving. They're changing all the time. We'll catch them. We put them in jail. They're literally, the behavior is going to go away and something new is going to come up. So we need to be able to alter what we're doing and what we're looking for, but use what we've learned in the past and just grow from that. And so I think employing some type of feedback mechanism, whether it is onto a supervised model, an unsupervised model, or whether you're shifting the model based on that data, that empirical feedback. I literally mean like variables and numbers coming back at you, and you're adjusting what you're doing. I think is key, and probably become more a bigger part of what we're doing, I think, in the future. But that's something that we've started playing around with great success. And the other thing too that I always want to stress with the methodologies that are being employed are, it's not always necessarily about using the most crazy tool set to get the job done. I think this is something that's lost a little bit sometimes. Um, Sometimes a simple univariate analysis will get the job done for you. Sometimes you need to know what the average is. Sometimes you need to know, you need to know if you have a threshold. Sometimes that threshold, it can be defined by a feedback loop. It can be defined by a model. Sometimes it can be defined by domain knowledge. In our case, that's what I mean by this is a very practical example. It's not uncommon for us to create a model to identify bad actors, and we know that there's going to be kind of an open door with the prosecutor to go after this stuff, because they want to shut something down. People are getting hurt, whatever. They're going to aggressively go after this, but they've kind of defined what those thresholds are. And so, although we might come up with some pretty nuanced ways to identify what they're looking for, and then maybe some related stuff, we really want to focus on what they're looking for. And so the domain knowledge, they're experts, not necessarily on the data analysis, but what's in the data, as doctors, nurses, or law enforcement personnel themselves. And they're going to say, hey, you know what, I think this is really where we want to focus because of a prosecutorial priority. And so, we'll drive down that road. And I don't think there's anything wrong with that. I don't mean to get into a giant debate about can we go down the road of automated feature engineering, or do we want to focus on domain knowledge? Where should an analyst be? But just from my perspective, I think there's room for both. And you just want to use the tool that's going to get you to where you need to be. You don't need to be fancy for the sake of being fancy. These tools are our tools. They're not what we're aiming for. We're aiming to get the results that we want. So we kind of use everything under the sun, whether it is a multivariate model, whether it is some machine learning algorithm, whether it's a feedback loop being incorporated there, or whether it's a univariate analysis, kind of the whole thing.
Yeah, fascinating stuff. You mentioned before that you can sometimes be dealing with 1 billion or 10 billion rows of data. So I was wondering, when you're working at that sort of scale, how do you? Maybe we can just walk through just a high level example. Don't have to be specific, but so say you have that much data, and you're looking to find an anomaly within that data. So how do you actually go about that? Like, what technology are you using for one? And then how are you overlaying the analytics methodology to be able to identify okay, like uh, maybe you can correct me here, but things like obviously someone is trying to claim too much, or there's too high a frequency of claims, or I don't know, maybe there's 10 other things that you could be looking for. But how do you actually go from nothing or raw data to some sort of insight?
Yeah, that's a great question. Kind of, yeah, bridges your previous question there, and what we're using and how we're doing that.
Mm.
So we were talking about tools before, and I kind of mentioned that my perspective is these are the tools that we have in front of us, whether it is a statistical methodology or a coding environment. These are all tools to me, and they are there for us as analysts and data scientists to use them to get to where we need to be. So I don't know. I'm not sure. I'll have to maybe talk with other directors and CEOs and managers of data science teams to see maybe where I fall in this. But I have opted to go to a direction that I call is tool agnostic, um, where I don't force a certain uh, processing mechanism or coding environment on my analysts or my data scientists. There are restrictions, of course, with resources. I can't bring them to the moon. I can't do that. But for example, in our shop, we use R, we use Python, we use SAS. There's others as well, and certain analysts, maybe they're more savvy in a certain line of business. Maybe they're more savvy working with a certain type of coding language, or whatever, and they kind of gravitate towards that, or a certain type of analysis. I like to keep that quote agnostic because the sometimes the certain tools are better at doing other things. So a package might exist in Python that, hey, works great for us, but maybe a similar package doesn't work in R. So if somebody has kind of pigeonholed themselves into only using R, or only using SAS, or only using Python, vice versa, whatever it is, there could be something in another solution that's going to get them to where they need to be. So I found it to have an arbitrary demand that we use this and only this environment, not to be helpful, and so I try to keep it a little bit more open. And again, I totally acknowledge that I'm at a larger company now, and so there maybe are more tools at our disposal than others, in kind of in this gamut of environment of data processing and storage. But I would argue that there's probably even more flexibility that could be out there. So with the context that we're using a wide variety of tools, it comes down to the methodology. And I guess first the exploration, and then the methodology that's going to be employed when you're looking at those 10 billion rows and you're trying to find the 1,000 that indicates that there's criminal activity occurring. And that will vary significantly based on the type of analysis that's being run. Generally, what maybe the buckets that I would create in the fraud space, and any payer would probably have, and I certainly hope my team is maybe doing this better than most, but in reality, we're all kind of on the same team here to fight fraud. But hey, we're going to have traditional kind of claims fraud, where a doctor is gonna try to bill for a service that they never rendered. It never actually happened. So you have to connect that world of, this is a procedure that didn't occur. How do but as someone who's looking at it from the claims system, or a claims processor is looking at it, all looks valid. But that happens to a certain extent of claims. How are you now going to identify something in front of it's not in front of you? You can't see that the doctor never rendered these procedures. How are you going to find that on the data side? Well, we can actually feel very confident that we can find that, kind of based on that out of the box thinking that we were talking about before, using these different methodologies, and engineering those features a little bit differently maybe than a claims processor would, or anyone else would, when they're looking at this stuff, to find out which stuff is going to stand out. I also, the other interesting thing is, I was speaking about the variety of tools that everyone uses, and they kind of use what they like, but there are some tools that are better at doing things as a whole. So not just, hey, there's another package I could download or something like that, but there's very specialized tools. So one of the things in our space that kind of becomes important, we do a lot of geospatial information systems analysis, or GIS analysis as well. So a lot of folks out there might have heard of Esri ArcGIS, or something similar. So it's very common for us to look at all right, in a given area, there's a bit of a geospatial disparity here that we wouldn't expect to see. So let's drive into that area. Let's see what's changing that at a geographic level. Are there certain doctors that are doing that? And if so, what are the behaviors of those doctors that differentiate them from everyone else? And all of a sudden now, you're starting at that super high elevation. You've got 10 billion rows in front of you, but you've just zeroed in on a couple of geographic areas. You've identified 100 doctors driving that geographic change. Now you're looking at those 100 doctors and you're wondering why those 100 doctors differ from the other thousands of doctors that are out there. And now you're starting to look at procedure codes or diagnosis codes, and you're able to differentiate and say, oh, okay, that's what's driving this. And the next thing you know, you're talking to investigators, you're talking to law enforcement, and saying, hey, I've got some aberrant behavior here. Another big one I would be remiss if I didn't mention in our space is link analysis. Link analysis is huge to see. Basically, where you've got the context is basically where you've got bad actors who might be evolving. There might be a situation, this isn't very uncommon at all, where you've got a bad actor doing something really bad. They could potentially be hurting or killing patients just for financial gain. They're identified, they're put in jail. They're gone. They're not billing anymore. They're literally in prison. But then there are associates that were tied to that physician that are now launching some new stuff. And hey, maybe it's not super close. They don't have the same name. Maybe they're not related. Maybe they're at a different address. But using link analysis, you can kind of start identifying, oh, okay, I can see how they're potentially connected here. And then obviously passing that information on to law enforcement and putting that in front of a grand jury is key when you're trying to go after those cases. So another kind of element that I suspect may grow in the coming years and decades, maybe not even just in the fraud space, but beyond, but is link analysis and seeing how entities and different identifiers are connected over time beyond
Mm-hmm.
what I would call the bread and butter statistical analysis applied to claims data. So some variety for sure.
Yeah, that is so fascinating, and I love the idea of being tool agnostic as well. And I think that is maybe um, something that more of us should consider, is that there's probably not one tool which is the best for absolutely everything. I mean, me personally, I'm sort of focused on Power BI, so I have a slight lean towards that. But there's certainly on the advanced analytics side, there's plenty of different tools that can do some quite advanced work and discover those insights in slightly different ways, that may be suited to specific environments or certain scenarios. So I certainly like that idea. Can what you work in is actually the things that you work on are so interesting. Are you able to maybe go into one of the most interesting insights you've found, or like one of the most creative like fraud schemes you've ever found, through analytics? Like, it would be so interesting to know, through an example, like one of the greatest wins you've sort of had with the work that you've done.
Yeah, you bet. I do have one of my go-tos that I always promise people when I present at conferences is the last time I'll ever share it, because I'm worried people are, oh, here he goes again, sharing the same story again. But it was a cool one. It's one I can talk about. A lot of times the cases that we work, federal law enforcement officers might be in undercover working at the facility, or someone's being put in harm's way, and so we literally can't talk about it. So there's so many things we cannot talk about because it's so sensitive, the nature of our work. But this one
Mhm.
is kind of played its course, and it was interesting to be a part of, and was personally interesting for me because it was right around the time that I had started my graduate work. I was pursuing and eventually wrapped up a master of public health from the University of Illinois at Chicago, because I won't get into that, there's another time, but I was interested in looking at populational health data and applying some of those methodologies in the fraud space. But it was interesting because there was a bit of a passion there for me for public health, and obviously I was working in the fraud space, and those two worlds unfortunately collided. It's certainly an interesting thing. We get excited finding the bad stuff and going after the bad guys, but and while that's the focus of our work, and I think that's what the public expects us to do, and that we do get excited about it, there is a bit of a dark side to this. This was several years ago when I was working as an analyst. I was looking through a lot of data that there were spikes in a certain procedure that I was kind of surprised to see. These were a very specific type of injection at the time. And it was a certain specialty of doctors, maybe more than a handful, but somewhere around there. We're not talking thousands of doctors. We're talking maybe hundreds or less in that vicinity that were kind of going after this. And looking at what they were doing, it stood out in the data when I was doing an analysis, and seeing a simple increasing trend. And I even did a bit of unstructured data analysis, looking at keywords and in some of the records that I was reviewing, and uncovered some interesting trends there. And after that kind of clued me in and threw up some red flags, I did a deep dive into this, and I kind of said, hey, this procedure is a fairly risky procedure. It seems to be on the increase. There's definitely, as there are almost always for all the medical procedures that we're dealing with, almost always, or there's a few exceptions to this, but most of them are valid procedures and they help thousands of people. We're not trying to shut them down at all. We're just looking for the ones that are taking advantage and putting folks in harm's way with it. And in this case, again, a risky procedure, and we're seeing some folks more than we'd expect undergoing it. And I published a report. This is probably one of the early reports that I had published, saying, "Hey, this is something for sent it off to law enforcement and insurance companies, saying this is something we might want to look out for. This has some red flags associated with it." Tragically, about a year after, or within a year of writing that report and releasing it, that very procedure led to a large number of people losing their life, hundreds of people getting sick, and unfortunately, this isn't something they're going to get cured from. But basically, we had several providers, but in this case, many providers using drugs from a what I would call a black market pharmacy, injecting those drugs from that entity into people's spines, into the epidural space of their spines. And it was an interesting case because it was a kind of a head-on collision of fraud and public health. Basically, what was occurring was, all of a sudden people were getting sick. They were getting meningitis, and it was being identified in their spinal cords, or they were in the epidural space, basically. But basically, looking at that, people are dying out of the blue. They're getting this procedure to help them with pain, and then a week later they're dead or they're horribly sick. And it's happening in certain areas, and the CDC's obviously monitors stuff like this, identifies it, and basically throws out there that, hey, we have a public health emergency here, which was kind of interesting, because a lot of times with fraud, you kind of keep it quiet until you're ready to do the criminal prosecution. You don't bring up a lot of details until you're have in front of a grand jury, and you're ready to take action that way and potentially throw some folks in jail and correct things that way. But in this case, there was an urgency with that. And so the CDC was, I wouldn't be surprised if they felt like they were being put in a bit of an uncomfortable position, because they're kind of having to jump the gun, assigning blame to say, hey, this is where this was happening. These are the folks involved. The criminal component, I actually was lucky enough to talk to some of the prosecutors who worked that case. I actually met with one at a conference after I was presenting their work, and my small part in it. But it was kind of cool to see the work that they had put into and all the efforts there. But when it was all said and done, it was many people had died. I think it was just under 100 people, and then hundreds were ill.
Mm.
It was a unique case where, actually, to this day, I think it's only been a few years where some of them are starting their prison sentences, but able to kind of shut something down quickly, and identify it quickly and protect the public so that it didn't happen to more people. The long story short version of what actually occurred is, there was a pharmacy who was trying to act like a drug manufacturer on the East Coast, skirting some laws so that they could sell more of these drugs that were used for the injections. But they were calling themselves a compounding pharmacy. You might have, if you watch John Oliver, he covered this in some detail. I covered it first, but he covered the topic of compounding pharmacies, and they're basically trying to act on the outskirts of the law, not following procedures to keep their clean room clean. They didn't have to be inspected because of kind of how they were labeling themselves, and basically just committing fraud is what it was. And then
Wow.
that led to the creation of these tainted medications. and then being sold fraudulently to providers who then use them and injected them into people just to make a couple extra bucks. And it was a really sad case, but early on in my career, and it's given me a lot of passion for what I do to try to prevent
Yeah.
things like that from happening again.
Yeah. Oh, and that is so interesting. So interesting. And I presume that you're dealing with these things on a monthly basis, just in a different variant.
Right. In fraud, you're exactly right. Fraud is weird because it's people trying to make money illegally. That's really what it is, right? They're trying to make a buck
Mm,
illegally. And hey, sometimes people end up just ripping off an insurance company or individuals or whoever for hundreds of thousands of dollars or millions of dollars, right? There's a financial cost there. But the other element that we prioritize, as everyone does, as Cigna isn't alone with it, and any special investigations unit with the government or in a private sector, is going to prioritize when there's patient safety involved. When hey, we're not just making a buck and stealing money, but we're stealing money and hurting or potentially killing people along the way. That
mm,
kind of becomes a priority. Yeah, and unfortunately, even myself, I get jaded in a positive way. You think this stuff won't happen after, hey, it's been a while since I've worked one of those cases. No, it's
mm,
happening all the time.
mm,
And so, yeah, an unfortunate part of what we do, but that's why we're here, and that's why we try to use the cool new tools to stop these guys dead in their tracks.
mm. Have you ever found yourself in a situation where you've realized some sort of scheme has been going on, but then um, once you identify it, you realize that it's been going on for like 5 to 10 years, and you've only just picked up on it, and then you've got to go back in the data and figure out, okay, this is when it started. You just sort of do like auditing and investigation. Have you ever had situations like that?
That's a great question. We usually the answer is sort of yes. That does happen in a way. We try to pride ourselves on staying on top of what's occurring, but we're not perfect. We're gonna miss stuff.
Mm, mm,
Usually, what I've kind of noticed is that we're looking for a certain type of fraud. And maybe that's occurring, or a version of that is occurring, but there's a bigger version of it that's really driving it. What we're seeing is just the tip of the iceberg, and we realize that something else has been occurring for some time and we need to shut that down. And
mm,
I have to acknowledge, of course, that yeah, I'm not perfect. One method that we kind of see, we're really lucky as data scientists because we literally have law enforcement and investigators in house, as all the companies do, that will look at cases, and some of the cases that they get don't come from us. Sometimes it depends on the company. Sometimes most of them come from the data scientists. Sometimes a small minority. It depends on your company and that. But hey, someone might call in. They might be an ex-wife, a recent ex-wife or ex-husband of somebody who works, and it does something fraudulent, and they'll report them or whatever, and so you'll uncover that
right.
stuff. But the benefit of that is that we get that feedback, so the investigators can literally tell us, hey, we're seeing an uptick, in this kind of fraud. What's going on here? And they'll reach out to us, and they're great about this. And we encourage that feedback, and I try not to always have it go down this road, but it certainly happens, and it's good when it does happen. We'll basically get to the point where we'll say, all right, we've got 20 new investigations specifically on this type of fraud. Let's go ahead and try to figure out what's happening here, and we'll do a deeper dive and uncover, oh, okay, yep, there's more entities going on. At the end of the day,
Mm,
we also ask ourselves, yeah, as analysts, as the data scientists looking at the data, why didn't we see this before the investigators, right? Why didn't we find that? And yeah, I'd be lying if I said that didn't happen. That happens industry wide, and I think that's something that keeps us up at night. We're always thinking about that. We're always trying to make sure that we're classifying this stuff correctly so that we're uncovering it. But for sure, yeah, for sure that happens,
mm.
that's kind of our battle every day, is to minimize the amount of time before it's uncovered. But yeah, you're right
Yeah.
on there.
Well, bad actors are can be very creative. So
Right.
you've got to be creative to combat it. In
Exactly.
most cases, it's not like everyone is running around trying to get caught, are they? So it's a constant battle. It's almost just like the government in the US got cyber hacked, right? It's like they don't want to be cyber hacked, but it can sometimes happen. Bad actors can be very, very creative sometimes.
Right.
Okay, so we've got to the hour. There's been a really engaging discussion. I've loved talking about everything we've touched upon. To round things off, what are some of, just quickly, what are some of the challenges that you face, and then also what are some of the opportunities for analysts generally, that you're seeing in like now and into the near future?
Yeah, some of those challenges, I think we touch on, especially in our space, the variety of data that we're dealing with, the tools in front of us. I think one of the things that I didn't touch on too much as well is the dynamic nature of the industry that we're working in, and this is also again kind of a bit of a double whammy where, if you looked at health insurance in the 1990s, things were very very stable, and probably very, very predictable. But boy, it's not like that currently. If you're a data scientist doing what we do on a daily basis, data science itself is evolving, as you cover that here, right here on this podcast. It's evolving so fast. So many changes, new tools, new statistical methodologies, new packages, new focuses, new priorities, just a crazy dynamic field. And then for us, healthcare itself is crazy dynamic now as well. Obviously, in the context of COVID, that's been a huge driver for us, in many of our claim systems throughout the world. All the payers are in the industry are talking about how, everything kind of just went sideways for us when COVID hit. We're used to seeing that similar, okay, here's where things go up and down over time, and this is going to happen in July, and we always know this is going to happen, and that's going to change, and it's just completely different. Add to that, there's political changes, that impact the nature of the business that we do, not just in the United States, but globally, that change things, and it changes the nature of the transactions and the relationships, and therefore changes the data that we're working in. So it's kind of a dynamic environment where a presidential election in the United States is going to impact the data that we're seeing 6 months from now. It doesn't really matter what side you vote for. It's more about, hey, we have to acknowledge that this is a dynamic situation. Things are going to be changing, and we have to be prepared for that. And that's a lot of work. It takes a lot of time, and then you're doing all that when you're coming from a space where you're a data scientist trying to deal with the changes there. It's a lot to take on. The good side about it, I think, is even though it is a huge challenge, it's not insurmountable, and it's fun. Let's be honest, it is fun. There's folks who, they'll do something in their careers, and God bless them if they do the same thing every day and they love it. For us, it's going to change all the time. So certainly some challenges there, but I think it's worth it. It's interesting, it's engaging, and it's there's nowhere else I'd rather be when it comes to the type of work that I'm doing. And I think a lot of my colleagues and analysts and data scientists would probably agree with that sentiment. So certainly no challenge that we don't enjoy.
Nice. And lastly, opportunities. So, opportunities in, say, the advanced analytics space.
Yeah, oh boy, this is if I feel really lucky. I feel lucky that I have, that I'm at where I'm at, and I have the opportunity to do what I do. Um, one of my favorite things to do is to talk to analysts and data scientists just starting off, or looking to go down this road, or starting off their career, or even not sure of exactly where their career is going to go in this space, and looking at what's going to happen for them in 5 years or 10 years as their own career develops, and they go into this space. The opportunities are limitless. You can, what we're able to do with the processing power that we have today, the methodologies that we have today, the machine learning methodologies that we're applying today, many of these we didn't even know that they would exist 5, 10, 15 years ago. To step into a world where that's the reality, that's just insane. I'm not going to say that I know exactly what the opportunities are going to be like in 5 or 10 years, but I can tell you they're going to be wild. The methodologies that we can employ, the growth in the tools, and how we can take a data set and move it around and look at it in a different creative way, like we've been talking about, the ease and the ability to do that, with what's being developed out there by vendors and companies throughout the world. we're at a very cool place, and I'm excited to see where that goes. Like I said, I'm not sure I even can say I can predict for sure that it's going to go in this direction, because a lot of these changes come from out of the blue, but boy, do they help us out. Is anyone kind of standing on the front door of advanced analytics? You've got a lot of new cool tools and opportunities sitting in front of you today that didn't even exist long ago, but you can only dream of the possibilities that are going to be in front of you in a few years and in the road to come.
I mean, we can both agree that the opportunities, whilst not even going into specifics, are just going to be massive. Like there's just going to be so many opportunities, and this is in my mind what I see happening, and kind of along the same lines as what you're saying, is that there's almost like this arms race in democratizing advanced analytics. And so all of the big tech companies are just going at it like crazy, trying to deliver tools and solutions where historically, even in maybe you just like could work in Excel, and now you can run these AI and sort of like machine learning models, and call yourself a quasi data scientist. And that, I think, is how that evolves, is what is going to open the door to tremendous opportunities and value creation like we probably have never seen. I was actually sorry, I'm just going on a bit, but I was actually watching this interesting YouTube clip from a well-known investor, and they were sort of saying that the value creation from deep learning, like machine learning, deep learning, AI, could be 3 to 4 times the value created by the internet. Like there's that much opportunity in this space, and where that comes out of, it's just going to be everywhere, right? Like absolutely everywhere.
I could definitely, I could see that myself, and it's interesting, trying to keep an open perspective here for data scientists in many industries. But if I kind of zone in on mine for a second, it's interesting to look back 15 years and see how data was a nice have. It was a nice thing to add to what you were doing, and I think that a couple years goes by, 5 years goes by, and now all of a sudden it's a necessary item. You're not going to be able to function as a company unless you're analyzing that data, even in this space. And now it's like all right, here's the methodologies that we're employing. There's an expectation that everybody needs to be at that same level if they're doing a good job, and so you can just kind of constantly see the bar raising, and everyone, at least as a minimum, needs to match that. And then when you look at machine learning, and you look at the possibilities there and the value add that you're talking about, I wouldn't surprise me if not only does the value add, the significant value add, and maybe that's hey, we're whatever that is in your sector, if it's tripling the value that you've got, or whatever that factor is, that's not just going to be a thing that, hey, this is going to be a great thing and we aspire to this, but it's going to be the new baseline. This is the expectation, because to survive in our world, we're going to need to be able to operate at this level. And then again, I think it's gonna raise again. So and I think that's a good thing. I think people are continuing to adapt, and that value add kind of becomes a requirement for the benefit, I think, of the companies involved in it, to make sure that they're getting everything out of the data that they can.
Yeah, totally agree. Well, Doug, I think we'll wrap things up. Fascinating discussion. Really enjoyed it. I can see that you've got an incredible amount of experience in this sort of area, and in leading things in this area as well. So you're really great to have you on the podcast, and I certainly feel like everyone's going to get a lot out of this discussion once we release it. So thank you so much.
Oh, Sam, thank you for having me. I appreciate it.
Okay, everyone, let's wrap things up for this particular episode. Thanks for tuning in. Don't forget to subscribe on your favorite listening app, and leave us some feedback. I'm always happy to hear from you. Okay, everyone, thank you so much.